Alright guys, in this video we're going to learn how to calculate or find angle measures in polygons. Alright, so some vocabulary words we're going to talk about today. First one's polygon, and a polygon is a plane enclosed shape made up of straight lines. So all of our shapes that are considered polygons have to be made up of straight lines. They also have to be enclosed, so they have to close out. You can't have any openings just hanging out to be considered a polygon. So a couple of examples. Notice how they all have straight lines and are enclosed. And then non-examples, we have a circle, or what looks like to be a circle, and another figure with two straight lines, but yet it has a curvy side right here. So these are non-polygons, these are polygons. Now regular polygon, it's not another way of saying normal, but regular actually means that we have side lengths that are all the same, and we also have all the interior angles measurements. Those are the same as well. So a regular polygon is a polygon with equal side lengths and interior angle measures. Alright, so interior angles and number of sides. The interior angles of a polygon are the angles that are located on the inside. So then in this figure, we have 1, 2, 3, 4, 5, 6, 7, 8 interior angles. And the number of sides will be denoted by the letter N. And we have 1, 2, 3, 4, 5, 6, 7, 8 sides to this figure. So N would equal the number of sides, and in this case it would be 8. Now, polygon interior angles theorem. So the sum of the interior angles of a convex n-gon is, well, just a real quick note, n-gon represents any sided polygon. So this could be a 13-sided, 14-sided, 1,000,000th sided. Just the n, again, remember, it stands for the number of sides. So to figure out the total sum of the interior angles of any n-gon, if you take the number of sides and subtract it by 2, take that difference and multiply it by 180 degrees, that'll give you the sum of the interior angles. So in example 1, we have to find the sum of the angle measures in a polygon. So we know that the sum of the interior angles is equal to n minus 2 times 180. So we need to figure out the number of sides, so we have n minus 2 180 really quick. Okay? And then the number of sides, we have 1, 2, 3, 4, 5, 6 of a hexagon. There's a convex hexagon. So the number of sides would be 6. So all we got to do is substitute in 6 in for n. Simplify. So 4 times 180, we get 720 degrees. So that means that all the angles on the inside, not the numbers on the outside, but the angles inside here, 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 and here, all of those angles add up to 720 degrees. Alright, in example 2, we have to find the number of sides given the fact that we know the sum of the measures of the interior angles. So it says the sum of the measures of the interior angles of a convex polygon is 1,260. We have to classify the polygon by the number of sides. So it tells us what all the interior angles add up to, which is 1,260. Usually, when we try to figure out the sum of the measures of the interior angles, we have to use n minus 2 times 180. But we know what that answer is. We know that the answer is equal to 1,260. We have to figure out what or how many sides this figure has. So working backwards, we know that this equals 1,260. So solving for n, we're going to divide both sides by 180 degrees. Simplify. We have n minus 2 equals 7. So then if we want to get n all by itself, we took away the parentheses because we don't need them anymore. We're going to add 2 to both sides. N equals 9. So then the number of sides is 9, and I'm not sure if it's a common polygon name, but a 9-sided polygon is called a nonagon. So then our figure is called a nonagon. Alright, the exterior and exterior angles theorem, I think it's supposed to just have one. We'll cross it out, exterior angles theorem. And basically the exterior angles of a polygon are the angles on the outside. Okay? So the sum of the exterior angles in every single polygon is always equal to 360. So these are all the exterior angles. If you add up angle 1, angle 2, angle 3, angle 4, and angle 5, notice how they kind of form if you go all the way around. What shape am I making here? A circle. So if you go all the way around, all the exterior angles should add up to 360. Always. So in example 3, we have to find the unknown exterior angles. So we know that this angle is 89 degrees. We know this one's 67, but we don't know what this one is or this one. However, if you look at the diagram, all these angles are exterior angles. So we just learned that the exterior angles all add up to 360 degrees. So let's write up an equation that represents that situation. So then 2x plus 89 plus 67 should equal 360 degrees. I'm going to combine like terms. We have 3x plus 156 equals 360. Solving for x, we're going to subtract 156 from both sides. We're left with 3x equals 204. Divide both sides by 3. X equals 68 degrees. So then we know one measurement, one exterior angle that we don't know is 68 degrees. The other one, well, we substitute in 68 for x, we get 136 after we multiply 68 by 2. The two unknown angle measurements are 136 and 68 degrees. Alright, example 4, we have to find the angle measure in a regular polygon. Again, a regular polygon means all the side lengths of this figure are the same, as well as the interior angles are all the same as well. So the trampoline shown is shaped like a regular dodecagon. A dodecagon is a 12-sided figure. So dodecagon's 12 sides. We have to first find the measure of each interior angle, and then find the measure of each exterior angle. So since it's regular, we know that each interior angle is going to be the same measurement. Now, what did we learn about finding the sum of the interior angles of any polygon? Well, we have to use n minus 2 times 180. So to figure that out, we have to use 12 sides minus 2 times 180 to find the measurement of the sum of the interior angles. So 12 sides minus 2 times 180, we get 10 times 180. So the sum of the measures of this dodecagon would be, the sum of all the interior angles would be 1080. So since it's a regular polygon, all the interior angles should be the same exact measurement. So if they all add up to 1080, if we take 1080 and divide that by the number of interior angles, each angle is 90 degrees. Wait a sec, let's scrap that for a second. I realized I made a mistake. It's not 1080, it's actually going to be 1800. So let's erase this really quick and write down the correct answer. So the sum of the measures of the interior angles of a dodecagon is 1800 degrees. Okay, so then since all in a regular polygon, all the interior angles individually should be the same, so then if we take, let's erase this real quick, 1800 and divide it by 12, then we know that each interior angle, when you divide 1800 by 12, you should get not 90, but 150 degrees. Okay, so let's check into that really quick. I just multiplied 10 and 180 wrong. So then each individual interior angle of this dodecagon is 150. Okay, so then in B, we have to find the measure of each exterior angle. So then, since this is a regular dodecagon or a regular polygon, not only the interior angles are all the same measurement, but the exterior angles are also the same as well. So, all of the exterior angles added together of any polygon is equal to 360. So if we take 360 and divide that by the number of exterior angles, we'll get the measurement of each individual exterior angle of this dodecagon. So we should have 150 for each interior angle, and then 30 for every exterior angle. Sorry for the mix-up, guys. Alright, if you have any questions, if there's any confusion whatsoever, definitely make sure you annotate and write down what was confusing, or if there were words that you didn't understand. That's definitely something that you should ask in class the next day. Alright, have a good night, guys.